Hello, and this is the Caroline Cymru revision session on chemistry unit, the ever-changing Earth, and in particular global warming, its causes, its effects, and tackling of global warming. So let's see the content that needs to be covered here. The first thing is to appreciate the relationship between the increase in carbon dioxide concentration and the climate change that's come with that, or the global warming that's come with that. So the first thing is to establish what carbon dioxide's role is in a normal situation, then, should we say. So there are a few greenhouse gases. The one that's most relevant to us is carbon dioxide. Methane's a greenhouse gas too, but carbon dioxide is the one that we feel is most relevant because it's the one that we have affected its atmospheric concentrations of in recent years. So that's the one we're focusing on. Now, regardless of whether it's in excess or there's more than normal, the way in which carbon dioxide works is the same. So when sun or solar radiation from the sun hits the Earth, it gets reflected back, and it gets reflected back as a longer wavelength radiation. It's a thermal radiation. And carbon dioxide traps that thermal radiation on the Earth's surface. So rather than that thermal radiation escaping back into the atmosphere, a proportion of that thermal radiation which has been reflected from the Earth and gets reflected back in, and that is done by, amongst others, carbon dioxide. So the more carbon dioxide you have, the more of that thermal radiation is getting reflected back and kept closer to the Earth's surface. Okay, so I'll say that again. You have solar radiation which reaches the Earth, it gets reflected back towards space. That when it's reflected, it's altered slightly. It's now a longer wavelength radiation. And rather than it being able to completely get back out to space, a proportion of it is reflected back again or re-radiated back towards the Earth. And that is done by greenhouse gases such as carbon dioxide. If you have more greenhouse gases, like more carbon dioxide, more of that longer wavelength, that thermal radiation is kept closer to the Earth's surface. And that's then what results in the warming of the Earth's surface. Now, we know that the percentage of carbon dioxide in the atmosphere is increased. We also know that's due to an increase in the burning of fossil fuels. And how do we know that? Because we know in the past 150, 200 years, the proportion of fossil fuels that have been burnt has increased a huge amount due to the Industrial Revolution and what's gone on beyond that. And in that time, we see the atmospheric CO2 levels has increased hugely from its baseline, its pre-industrial levels. And sorry, to add on to that, so we know that carbon dioxide levels have increased significantly. We know that that's happened at the same time as increase in fossil fuel being burned, but we also know that global temperatures have increased during that time too. And because we know the way in which carbon dioxide and other greenhouse gases trap that thermal radiation closer to the Earth's surface, it's an easy step to make to say, well, that's very good evidence that it's the increase in CO2 levels that has caused the warming of the Earth, the global warming. Okay. Now, lots of studies have been done on this, and lots of studies have agreed that it's the rising CO2 levels that have caused that climate change. And because many scientists do many studies have formed this conclusion, I've got evidence for this, we're confident that in the evidence, and we're confident and that's the case. There will always be there's always likely to be some who will disagree, but the overwhelming majority of the studies and the scientists that look at these studies or carry out these studies, the overwhelming majority agree that the rising CO2 levels has caused the climate change. Okay. We've got very good evidence for what's happened to CO2 levels in recent years. I'd say the last 50 or 100 years. We can actually go back further, but the instruments used or the methods used are not as good as the ones we use nowadays. So we say they're less precise than the current measurements that we have. So let's have a little look at what that can result in. What are the consequences of that climate change, that global warming? Well, be easy to say, well, it'd be easy to assume that just everywhere's going to get hotter, but actually the climate change is what the climate is going to change is what we say. Rather than just call it global warming, we know that whilst that is true, the climate is going to change. It's going to change in differently in different places. So some places will get hotter and drier, so you get droughts there. See the effect then of difficulty in growing crops. Others will get lots of rain. You get lots more flooding and actually difficulty in growing crops and all the other things that will come with that. We also know that climate change is going to cause a melting of the ice caps, the polar ice caps, and that will cause a rise in sea level. So some areas on the planet that are currently habitable will not be habitable any longer because they'll be covered in water. There are certain areas that on the planet which are below sea level, and those that just a couple of meters above sea level are also going to suffer because the sea level will rise. So what are we going to do about it? Okay, so what we can do is we know what it is, what are the consequences of it, and how do we go about reducing that or mitigating that? So what we can do? There's a few options. First of all, we can use renewable energy sources. Okay, things like solar power, wind power, tidal power, even using nuclear power, whilst that can be somewhat controversial because of the wastes involved and the potential dangers involved. It's greener in terms of CO2 concentration, CO2 emissions than our current way of power stations that we currently use. Other ways we can do it, governments can tax companies if they produce lots of greenhouse gases, and so that incentivizes them and encourages them to find alternative ways, either reducing their electricity use, for example, thus reducing their greenhouse gas emissions, or finding alternative ways to produce the same level of electricity using renewable sources. The other thing some companies will try and do, because it's well, companies may well feel they have a duty to do this, or indeed they think it will be seen positively by their customers, is you can offset the CO2 that they emit. So every time you emit a proportion of CO2, you plant some trees, and you pay for the trees to be planted, and that removes the CO2. You can do this when you buy a flight. You often have the option of paying to offset the carbon. Flying produces an awful lot of CO2, and so you can pay a little bit extra. And the idea being is that company then uses that money to pay for trees to be planted, and that removes CO2 in the process of photosynthesis. And I think customers will often do that to make themselves feel better about flying places and emitting a lot of CO2 or contributing to CO2 emissions. They can pay for trees to be planted. And the other thing that can be done is you can use carbon capture or carbon storage, or to combine them really, is carbon capture and storage. So where CO2 is captured, say by a power station, so as CO2 is being emitted, at that point, technology is used to capture that CO2 and to store it underground, and so it's not released into the atmosphere. Okay, so really the reality is that, there's a number of different things that can be done there, and the reality is that they will all need to be done in order for us to slow down this CO2 emissions, these CO2 emissions that we currently have, which are very high. We're trying to reduce that. You might have heard of the idea of becoming carbon zero or carbon neutral, the idea that the CO2 you produced is equal to the CO2 that you use up. And so that would be the ideal situation, that even the whole countries can become carbon neutral, or they call it net zero, that whilst they may produce CO2, they're also taking CO2 out of the atmosphere in some way. So that overall, the idea being that overall they don't produce any CO2, they're not adding to the current CO2 levels. Right, there's quite a lot of information there. And so what I would encourage you to do is you can pause the video and you can try and do this fill in the blanks exercise. And then check it afterwards, or you can just go through it with me now and see how you get on. So what should we got here? Greenhouse gases like carbon dioxide only absorb the longer wavelength or the thermal radiation that gets radiated back from Earth, so warming the Earth's surface. The percentage of carbon dioxide in the atmosphere has increased due to the increased burning of fossil fuels. And at the same time, the global temperature of the Earth has increased as well. And we have many studies that agree that the rising CO2 levels has caused this climate change. So we're increasing the confidence in the evidence. We do not have historic data on CO2 levels and ways to estimate past data. Sorry, I said that wrong. We do have historic levels on CO2 levels and we have ways to estimate past data, but these estimating ways are less precise than current measurements. Climate change likely to cause some places to be hotter and drier, so that's going to cause droughts, while others get more rain, so causing flooding. Climate change is also likely to cause melting of polar ice caps, causing a rise in sea levels. And then we can reduce greenhouse gas emissions by using renewable energy sources or by governments taxing companies more if they emit more greenhouse gases. Companies can offset the CO2 they emit by paying for trees to be planted to remove the CO2 in photosynthesis. And finally, it's carbon capture and storage is where the CO2 is captured before being released into the atmosphere, then storing it underground. Okay, let's have a look at a question then. So in this question here, it's a foundation question, I believe. It looks what it's asking you to do. The following pie chart shows the source of greenhouse gas emissions in the United States. Always when you're given some new information like this, it's worthwhile, whether it be in a table or a pie chart like this, to just take one piece of information and think about what that's telling you. So rather than me just looking at these numbers and words, I said, well, okay, so if I combine what I'm seeing with what it says at the start, in the stem of the question, I can say that, so in the United States, transportation results in 27% of greenhouse gas emissions. And in the United States, agriculture results in 7% of greenhouse gas emissions. Okay. Now the question is, calculate the percentage of emissions from electricity generation. So electricity generation is the one that you don't have any value for at all. What you're required to appreciate here is the whole pie chart combined equates to 100%. You're given all the others, so you need to add together agriculture, residential and commercial, industrial and transportation. So the 7, the 11, the 20 and the 27, and that gives you a value of 65%. And the whole lot equates to 100%. So I do 100, take away the 65, it gives me 35. So the percentage emissions from electricity generation is 35%. And if I look at whether that wedge looks like 35% of the whole, I would say yes, it probably does. So I'm quite happy with that. It's always a good idea to check, particularly in maths questions, does it look right? Explain why scientists are concerned about the release of greenhouse gases such as carbon dioxide into the atmosphere. Well, the idea that here they want is that the increased temperature, that the release of greenhouse gases causes an increased temperature of the Earth's atmosphere, or just saying global warming would be fine there. And one of the consequences of that is 2 marks. We need to say some more. So the idea that ice caps melt faster, that we get climate change, there's more flooding, there's more extreme weather. I think, they've emphasized here, you need a comparative word. You can't just say flooding, because flooding happens now and has happened for, for thousands of years. So what we're saying is that increased level of greenhouse gases causes more flooding. It's quite common they insist on using a comparative term like that, so saying faster or more. So just one way to reduce the amount of greenhouse gases released into the atmosphere, well, you can use renewable energy sources, or you could name one. Okay, there's a list of them there, or you can say carbon capture and storage. Okay, any of those would work. And I think everything on there, it seems pretty straightforward. This is perhaps a harder question here. So this shows the look what it's happening. What they're telling you. The satellite images are used to show the area of Arctic sea ice. This is so this is your landmass in grey. The white is the ice, and the darker color, the dark grey or the black there, that's the sea. And this line here shows the position of the sea ice in 2000. And now now you can see where the boundary of the sea ice is in 2012. So you can see that that sea ice is shrinking. And it says the shrinking of the ice cap is interpreted by environmental groups as the result of global warming. State and explain the main cause of global warming. State and explain the main cause. So state, what's the cause? The cause of global warming is increased fossil fuel use, burning more fossil fuels, and explain that. Well, that means there's more carbon dioxide emissions produced. And you could have said as well, I think I might have also added on, I would have probably said that, and that traps that thermal radiation towards the Earth's surface. Don't get a mark for it, but you don't know, of course, what's on the mark scheme, so you just give lots of information, correct information. Give one consequence of the reduction of the Arctic sea ice. Well, the obvious thing here is rising sea levels. Or you can see other things on there as well. But I think for me, the logical thing would be to say rising sea levels. So a couple of questions on there to see what you can, see what you can expect. They're largely straightforward. There's quite a lot of information there to know, but the questions seem to be quite straightforward to go with that. I hope you found that useful. You can check out the Callum Company website to get more videos on multiple different subjects. So please go ahead and look at that. And I hope that was useful for you today.